Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving deep into a fascinating paper, Thought Anchors, which LLM Reasoning Steps Matter. It's all about trying to understand what's really going on inside these large language models when they're supposedly reasoning.
Yeah, I'm really excited about this one. It seems like we're finally starting to peek under the hood instead of just throwing more data at the problem and hoping for the best. I mean, these LLMs are getting incredibly powerful, but are they actually thinking? That's the billion-dollar question, right?
That's exactly what I'm skeptical about. Are they just sophisticated pattern matching machines, or is there some genuine reasoning happening? This thought anchors idea seems like a step in the right direction, but I still think we're a long way from AGI with the current deep learning paradigm.
I agree with both of you, actually. They are pattern matching machines, but the patterns they're matching are getting increasingly complex. And I think the key to unlocking true reasoning might lie in understanding how they represent and manipulate information, particularly spatiotemporal information. This thought anchors concept could be a piece of that puzzle.
Okay, so for our listeners who maybe aren't as familiar with the term, what exactly are thought anchors in this context? How are the researchers defining them? And why are they important?
From what I understand, they're essentially trying to identify the crucial steps in the LLM's reasoning process, like the specific points where the model is making key inferences or drawing important connections. They're treating these steps as anchors that the rest of the reasoning process is built upon.
Right, but it's not just about identifying any step. It's about figuring out which steps are the most critical for arriving at the correct answer. Which steps, if removed or altered, would significantly impact the model's performance.
And I think the underlying assumption here is that if we can pinpoint these critical steps, these thought anchors, we can start to understand the underlying algorithm that the LLM is using. We can get a glimpse into its internal representation of the problem.
Exactly. So the paper probably dives into how they're identifying these thought anchors. What methodologies are they using? Are they looking at specific neuron activations, or are they analyzing the text generated at each step?
From what I read, they're primarily focusing on analyzing the text output at each step of the reasoning process. They're using techniques like ablation studies, where they selectively remove or modify parts of the generated text and see how it affects the final answer. It's like a surgical approach to understanding the model's reasoning.
Which to me feels a little bit superficial. It's like trying to understand how a car engine works by just looking at the exhaust fumes. You might get some clues, but you're not really seeing the underlying mechanics.
I see your point, but I think it's a necessary first step. We need to start somewhere. And analyzing the text output is a relatively straightforward way to get a handle on what the model is saying it's doing, even if it doesn't tell us how it's doing it.
Yes, and I think it aligns well with the challenges of LLMs. They're language models, so it makes sense to start with language analysis. But you're right, Sarah, we need to go deeper eventually. We need to start looking at the neural level, at the activations and the connections to really understand what's going on.
I agree. And I think that's where the real potential of this research lies. If we can link these thought anchors, these critical reasoning steps, to specific neural activations, we can start to build a bridge between the human brain and AI. We can start to understand how our own brains perform similar reasoning tasks.
But that's assuming that the way LLMs reason is even remotely similar to how humans reason. And I'm not convinced that it is. We use symbols, logic, and a whole host of cognitive tools that are simply not present in these purely statistical models.
That's a valid point. But even if the underlying mechanisms are different, the end result might be the same. The LLM might be arriving at the correct answer through a different route, but it's still arriving at the correct answer. And understanding that route, even if it's not the same as ours, could still be valuable.
It's like, imagine two different algorithms for sorting a list of numbers. One might be more efficient than the other, but both achieve the same goal. Similarly, LLMs and humans might use different algorithms for reasoning, but both can arrive at intelligent conclusions.
Exactly. And I think this research on thought anchors is a step towards understanding the algorithm that LLMs are using. By pinpointing the critical steps, we can start to reverse engineer the process and figure out how it works.
Okay, but let's say they do identify these thought anchors. What then? How does that actually help us build more intelligent machines? Is it just about making the existing models more efficient? Or is there a deeper potential?
I think the potential is much deeper. If we can understand the underlying principles behind these thought anchors, we can potentially design new algorithms that are specifically tailored for reasoning. We can move beyond the brute force approach of deep learning and create systems that are truly intelligent.
Yes, and I think it could also help us to build more robust AI systems, systems that are less susceptible to adversarial attacks or unexpected inputs. If we understand the critical reasoning steps, we can design mechanisms to protect them and ensure that the model doesn't get derailed.
And it could also help us to build more explainable AI systems. Systems where we can actually understand why the model is making a particular decision. That's crucial for building trust and ensuring that AI is used responsibly.
That's the dream, right? But I'm still worried that we're putting too much faith in the current deep learning paradigm. I think we need to start exploring alternative approaches, like neurosymbolic AI, that combine the strengths of neural networks with the power of symbolic reasoning.
I'm with you on that. I think we need to be open to all possibilities. And I think the key is to focus on the underlying representation of information. How are these models representing knowledge, and how are they manipulating it? That's where the real breakthroughs will come from.
So, practically speaking, what kind of research would you like to see coming out of this thought anchors idea? What are the next steps that researchers should be taking?
I'd love to see more work on linking these thought anchors to specific neural activations. We need to start using techniques like fMRI and EEG to see what's happening in the brain when humans are performing similar reasoning tasks. That's how we can really bridge the gap between AI and neuroscience.
I want to see more research on neurosymbolic AI. We need to develop algorithms that can combine the pattern matching abilities of neural networks with the symbolic reasoning capabilities of logic and knowledge representation. That's where I think the future of AGI lies.
I want to see more research on spatiotemporal reasoning. We need to develop algorithms that can understand and manipulate information in space and time. I suspect the core algorithm needs to be able to translate between different coordinate representations. That's crucial for understanding the world around us.
From my perspective, I think we need to focus on understanding the neural underpinnings of reasoning. How do neurons and synapses work together to generate thoughts and ideas? If we can unlock the secrets of the brain, we can build AI systems that are not just powerful, but also understand the world with a deeper, more human-like intelligence. Also, I'm very interested in the Otto model that, despite its seemingly simple rule set, presents an intriguing opportunity to examine the fundamental principles of how an agent can build and utilize a mental model to anticipate and react to opponent actions. How can we computationally model the agent's internal model and the dynamic interactions within this world?
That's a great point. And it's important to remember that this is just one piece of the puzzle. We need to be exploring all avenues, from neuroscience to computer science to philosophy, if we want to truly understand intelligence.
Absolutely. And we need to be critical of our own assumptions. We need to be constantly questioning whether we're on the right track and be willing to change course if necessary.
Agreed. The pursuit of AGI is a long and challenging journey, but it's a journey worth taking. Because if we can unlock the secrets of intelligence, we can solve some of the world's most pressing problems.
Well, that's all the time we have for today. Thank you all for joining me for this fascinating discussion, and thank you to our listeners for tuning in. We hope you found this conversation informative and thought-provoking. Until next time, keep exploring.
Thanks for having me. It was a great discussion.
My pleasure. Always a pleasure to debate these topics.
Likewise, let's keep pushing the boundaries of what's possible.